Morning, this is your stats sensei, Mr. Spensei, and we're looking at a problem that deals a lot with the geometric and the binomial. So this is 2011B is the year for question number 3, and the airline claims that there's a 0.10 probability that a coach class ticket holder who flies frequently will be upgraded to first class on any flight. The outcome is independent from flight to flight. This is important because our probability is fixed. We know that because each one's independent. This lets me know I'm working with some sort of Bernoulli, and geometric and binomial are both Bernoulli. Sam is a frequent flyer who always purchases coach class tickets. What's the probability that Sam's first upgrade will occur after the third flight? Well, the key word here is first. First indicates that we're looking for some sort of geometric. So we're going to go ahead and write that down that, hey, you know what? We know it's a geometric and we know our probability is 0.10. And so we now have our test named. So we're wanting to know will occur after the third flight. So that's the probability that X is greater than 3, where X is the number of flights until the first upgrade. All right, so let's look at this. So we go to our number line, and our number line says, well, geometrics always start, number lines always start with a 1. So 1, 2, 3, 4, 5, and technically they go all the way to infinity because we may never have that first upgrade. We want it to happen after the third. So what we're interested in is this. Well, when we go to show our work, we can't show all the way to infinity, so we don't try. We show the part below and we subtract. We're going to do a 1 minus and 0.9 to the 0. That's the probability of failure. And this is the probability of success. And this is our first term. Notice my exponent in this matches, plus 0.9 times 0.1. These are both to the first. And notice that's my second term, and my exponents match that, plus 0.9 times 0.1. And by the way, the success is always 0.1, and that's always going to have that exponent. This is my third, so this has to be 2 because 2 plus 1 is 3. So there is my work shown. All right, so on the calculator, we're going to go 1 minus second vars, 1 minus second vars or distributions right here, that button right there. Scroll all the way down to geometric CDF, and we know it's a CDF because we have more than one value. Anytime you have more than one value, it's a CDF. Press enter. Our probability is 0.1. Our X value is 3. Why is it 3? It's because that's the largest value we were subtracting out. So you always the largest value subtracting out. And we get 0.729. If you had all of this, you would have gotten full credit or an E for this part of the question. All right, part B. What's the probability that Sam will be upgraded exactly 2 times in his next 20 flights? Well, here I have a specific number of trials. The fact that I have a specific number of trials lets me know that this is the binomial. And our trials happens to be 20. And my p-value is still the 0.10 that we were dealing with before. This keyword exactly tells me what type of we're looking for. And so we're looking for the probability that X equals 2 where X is the number of upgrades. Well, in this case, we're looking for the probability that X equals 2. And because this is a singular specific value, this is going to be a binomial PDF. If we were making our number line, we'd go, well, binomials always start with 0, and it's 0, 1, 2, 3, ... all the way to 20. We're only looking for the singular value. Anytime we're working with a singular value, it's going to be a PDF. My work is going to look like this: 20, choose 2. By the way, this formula is on the formula chart, and it's actually labeled binomial. N is my number of trials, X is 2, there's my probability. So 20, choose 2, 0.10 squared, 1 minus that, which is I'll just write 1 minus 0.10, but it's 0.9. And then 20 minus 2 is 18. These exponents must sum together. So when I go to that, I'm going to go second vars. It's a binomial PDF because it's only a singular value that was selected. Our trials, well, we said that there were 20. Our p-value, 0.1. And our x value is 2. And so we end up getting 0.28517. And that will take care of our answer, and we're done with that part. Now we're going to move on to part C. So Sam will take 104 flights next year. All right, that's important. Would you be surprised if Sam receives more than 20 upgrades to first class during the year? Justify your answer. Well, we have a specific number of trials. So this lets me know, hey, we still working with a binomial. Our trials in this case, instead of being 20, is now 104. Our probability has remained the same at 10%. And so we want the probability that X is greater than, probability that X is greater than 20, where X is the number of upgrades. So let's take a moment and draw our number line out. And our number line is going to look, and I just misplaced the pen. Our number line is going to look something like this. Binomial always begins at 0. So we have 0, 1, 2, and I'm going to skip 19, 20, 21, 22, ... all the way to 104. And the part that we are interested in is a probability that it'll take more than 20. So we're interested in these values. Well, there's no way I'm going to show all of those PDFs, but we know we're going to be working with a CDF because we have more than one value circle. So here's my work shown. Starting with the lowest that we want, which is 21. 104, choose 21. 0.10 to the 21st power times 1 minus that is 0.9. Just a moment. So this is to the 83rd power because these two have to sum up, plus ... plus 104, choose 104, 0.10 to the 104th times 0.9 to the 0. That's my work shown. All right, it's not the only way to show the work, but that's one way to show the work. But on the calculator, we can't do all these PDFs. So what we're going to do is we're going to do a 1 minus. So for our calculator, We're going to go 1 minus the binom CDF. Our trials will equal 104. Our probability is going to be 0.10. And our X value is going to be the highest value we didn't want, which happened to be 20. So here we go. 1 minus second vars right there where it says distributions. And binomial CDF trials is 104. Our probability is 0.1. And the highest X value we didn't want was 20. And we end up getting a pretty small probability of about 0.0013. Guess what? If we only showed that, we didn't get full credit because we haven't answered their question. Would you be surprised? Well, the answer is yes. I would be surprised if Sam got more than 20 upgrades. Why? Because there is only a 0.13% chance of that occurring, right? Because there's only a 0.13% chance of that occurring. All right, so in that case, we had to make sure that we showed our work and answered the question. Always make sure you answer the question. Yes, I'd be surprised if Sam got more than 20 upgrades because there's only a 0.13% chance of that occurring. Well, I hope that helped on the binomial and geometric, and I look forward to seeing you on the next one. Thank you.